idea is to introduce to artificial intelligence. When that introduction is done, then we would happily meet again in the next class, which is on Sunday, and then we'll begin to look deep down into the very issues of artificial intelligence. All right. So the question we'll be trying to quickly answer now is what is AI? And then we also try to look at the foundations of artificial intelligence. And then we also discuss the state of art issues on artificial intelligence. Okay, state of art is making reference to state of the art is making reference to the very current or I don't know which word I will use, and then you can easily familiarize yourself with this. Maybe trending would also do. Trending. What is trending with AI? The current state. What has been the past with artificial intelligence, and then what is happening now? And what do you think the future of artificial intelligence would be? Okay, that is the issue of the state of art. All right. So with us as human beings, our major idea has been on how we think. Try to understand how we think. That is to also find out how a handful of matter can perceive, understand, predict, and then manipulate a world far larger and then more complicated than ourselves. This is how the human being psychology works. So the things that we see now, we try to perceive through it to have people's perception on how these things that we see around us were formulated, how were they made. We try, apart from perceiving, also trying to understand. Okay, we try to understand how this perception came about, and then we use that as the basis to do prediction of what the future would be. Anytime we predict it means that we want to base on the past, the historical data, the information that we have gotten to know earlier on, to benefit from that, to suggest what the future is going to be. So if you take a typical situation, for example, in weather forecasting, how is weather forecasting done? Weather forecasting is done typically by relying on what? Weather forecast data, or simply put, for example, the temperature at a point in time T, the humidity, the moisture or the content of moist in the air. All of these parameters have been recorded day in, day out for only God knows how many years. And then they rely heavily on this past data, this historic data of the weather, to predict how the weather will be tomorrow or some days to come. Do you understand? So in artificial intelligence, these are the fundamentals. Making predictions. The predictions are based on what? On the past. Okay. You can only begin to make predictions if you understand the common grounds for which the immediate situations now are taking place, inclusive of what? Of the past. Then you can make prediction of exactly what will happen to the tomorrow. Okay. So likewise in artificial intelligence, the fundamental issue is to borrow how the human brain do perceive, how it does understand, and then also based on this same to do what? Prediction. Quite apart from that, you'd also want to move ahead to do some types of what? Manipulation. Why manipulation? You may have a target predicted issue that you're looking at. You will need to manipulate the values or the variables that you have to so as much as that it can give you the prediction that you are looking out for. Okay. So in the field of artificial intelligence or AI, it goes further still to make attempts not just to understand, but also to build what? Artificial entities. That is why I said that one of the very objectives of this class is to build intelligent software, and then what? And then hardware. Pardon me for my Saito handwriting, okay? Uncle school papa. So we're trying to build intelligent systems, okay, that will come in the form of either hardware or a software. Currently, there are two paradigm shifts with artificial intelligence coming in either of these two forms. That is in the general note learning and then perception, and then more specifically, AI has been deployed successfully in the area of games. For example, in chess, you know what chess is, right? Uh, chess, chess, where you damn you, the big game. What did I say? So playing chess, AI has been successfully deployed. So then the best chess gamer in the world has been outwitted by the artificial intelligent agent, which played with the best chess player. Okay, it has also been successfully deployed in the proving of mathematical theorems. So when it is giving data of the past, how these theorems have evolved, how they have been solved over time, AI has comprehensively been able to solve these problems also. And then also in the writing of poetry, poetry has been very difficult. That you would need to be that creative to know how people have written poems, to know the poems that are already out. So then you don't write one that is the same as an existing poem. That would be like a plagiarism. You have copied people's creative art. Okay, so in this case, you're going to have several scripts of poetry that will be given to your computer system, and then you are expecting that your computer system would learn from the given set of poetry scripts to come up with an entirely new poetry. Okay, so it doesn't exist. That is what we are looking out for. So AI has been able to help us achieve this successfully also. You are asking me if you can shift the classes time from 6:30 to 4:30 because I travel miles to the next town for lectures. Hey, Samuel Ben, why have you turned on a video? My guy, what's up? Hey, but you resemble AY Poyu small. Your brother that. Don't mind me, I was just kidding. My good friend, you would have to turn off your video. If you don't turn off your video within 1 minute, I'll kick you out. We should change the classes time from 4:30 to 6:30. Watch it. That time wouldn't be favorable. Okay, it wouldn't help me either. So I would beg of you to try and then make adjustment.
Sir.
Please, all of you who would want to communicate, type them in the chat panel. Kindly do that, please. If you have any issues, type them in the chat panel. I'll look at it. I'll give you feedback. All right, so my good friend, I'm 100% sorry. I wish I could make a change to the schedule, but as it stands now, I have a lot of classes to teach. And then this time, I kept quiet to handle this course because it fits. It fits the period I can sneak in and then teach. Okay, I'm teaching regular students also, and I have to teach your section. If I make the change, it may even conflict with some other timetable of your other colleagues, right? So please do consider all of us and then make a change instead with your schedules, and then this class is not going to run forever. It's just for that short period. All right, thank you. All right, so let's do this. I would answer all concerns that do not relate to what we are supposed to learn now after class. Do you understand? Otherwise, it will really be a distraction. Okay, so for now, ask questions only about what we are discussing. Issues of what time we should meet, where I should put note and the like. It doesn't relate to what I am teaching now. Help me to teach you better. Don't ask me questions that do not relate to the content we are discussing. Okay, I know you teach also, so you should appreciate the direction I am coming from. Ask questions that pertain to AI. For now, leave out issues of where the notes will be, if the note will be in heaven or it will be in hell. Any of them where I can put them for you to download is okay. My guy, let's do some AI more. All right, so like I was saying earlier on, it has been applied successfully in the area of playing chess, mathematical theorems, and then its application also in the writing of poetry. Poetry, machine learning has been used heavily in this area. Okay, machine learning and then deep learning. Even in the area of movie production, there is one movie that has been produced using deep learning. You can check that out after today's class. A movie produced, I don't know, I think it is by IBM. IBM, their data science engineers, they have modeled a whole new movie. When you listen to the conversations in the movie, you tend to understand that some of the sentences do not make a lot of sense because they are still trying to improve the models that were used in creating this movie. What I will need you to appreciate that movie was built 100% from an AI machine learning and deep learning technique. And then also, you might have heard of this new idea that is coming up with driverless vehicle. Immediately, GPS could make it possible that we could navigate from one source to a destination, moving from one place to another. It was also possible that now you can give the car itself an intelligence that will help you move from one point to another without what? A driver. For more than 20 years, aeroplanes have already had that autopiloting, although there's going to be that physical human being pilot. But when you put the aeroplane in the autopiloting, it is going to move directly to that particular destination. It can drive, it can drive even when there is what? Turbulence and all of that. It can have its own adjustment. Okay, so this is purely done by what? Artificial intelligence. So with the concept of driverless vehicles or driving a car on a crowded street, all of these things have been successfully been implemented. Would Steven kindly turn off your video, otherwise I'll help you out. And then also in the area of diagnosis of diseases, okay, it has also been so much successful. More of that is relying on the concept of what? Expert systems. So the expert system, Steven, should I turn off your video for you? Your kids are even crying.
I've done that, sir.
Give the kids food so then they can keep quiet and you can also learn. About 7:15. Come to your mom, Diane. Watch it, mama, watch it. Me lobis no, but we see the boost for mama. Fancy for 1 million, no, for mom, no money free. Let them be okay, and then you can also be okay to learn. Right? So, these are more some selected few areas for which AI has been specifically deployed. So then they are also noted to be successful. So let's simply put, in almost every other area as it stands now, AI has been deployed. Okay. Now let me see if you're able to follow. Apart from these examples that I have mentioned by the slide, which other area do you think AI, artificial intelligence, has been used? Give me your response in the chat panel. I'll look at it. Look at it. If it's in direction, I'll say yes. Otherwise, I'll say no. Military situations. Which situations are those? Is it you to bomb the banana AI and bomb nana anything? In drones. Yes, in drones, that's correct. When it comes to robotics is already AI. Evans means I turn off your video. Yeah, in guidance and counseling, yes, some AI has been deployed. So they need to learn from past data to make some recommendations for people. Yes, that's true. Have you heard of you know of e-commerce, right? E-commerce is buying and selling online. I hope you are all aware of it. Now, in buying and selling online, or simply put in e-commerce, you would have seen, for example, that let me mention some local ones. I don't know if in the local ones this same thing happens, but if you go to eBay, anytime you selected an item for which you wanted to buy, based on the item that you selected, whether you bought them or you moved them into your cart, the application in itself will begin to suggest or recommend to you some new items for which you may be interested. So, for example, if you bought some t-shirts, or you added t-shirts to your cart, or you bought some, let's say, some Nike footwear, or you bought some glasses, it will look at the fact that you have bought some t-shirts, you bought some Nike glasses, so it begin to suggest to you t-shirts that you have not yet looked at, some Nike footwear you have not yet looked at. If you didn't get this example right, let me use one I know for that. No matter what, you should be able to relate. On YouTube, if you have been watching videos that relate to athletics, okay, and then you log in again. In the next login, it will begin to suggest to you some videos about athletics that you had not yet viewed. Okay, all of these things are done based on the concept or technologies or techniques from what? Artificial intelligence. Okay, so the system is designed and modeled in a way that it will learn your behavior. And then it will use that to make recommendations to you. In agriculture and then farming. In agriculture and farming, how is the AI deployed? On YouTube, that is correct. In agriculture and farming, that is true. On Jumia, I don't know if Jumia has that intelligence. I have not used much of Jumia. Help desk management, yes, help desk management. More of it, they come in the form of a chatbot. Yes, on Alibaba, it is applied heavily. I have used Alibaba over and over and over again. It is used heavily. They have this also. They call Taobao. Taobao is one of the most trending e-commerce sites in the world. It relies heavily on machine learning and deep learning to make recommendations to buyers. Okay, so I think you are able to follow. Right, so moving on, these are highly achieved because of what? Artificial intelligence. As it stands now, we have not defined what artificial intelligence yet is we want to look at the definition of AI from 4 different categories of definitions that have been shared. Number 1, that is looking at AI as thinking humanly. Number 2, acting humanly. Number 3, thinking rationally. And then the last quadrant, acting rationally. Right? So in the first definition by Hogland, written in 1985, he defines AI as thinking humanly to suggest that the exciting new effort to make computers what? Think, machines with minds in the full and literal sense. So they are looking at the fact that computers will begin to think and then make decisions, make suggestions, just as human brains will be able to look into issues and then make what decisions. Similar manner, Bellman in 1978 also looking at AI as thinking humanly suggests that it is the automation of activities that we associate with human thinking, activities such as decision making, problem solving, and then learning. It is human beings that make decisions, that look into problem and then try to find what solutions to it. It is human beings that do what? That do. But as it stands now, artificial intelligence systems, either a software or hardware, is also giving the same capability, so then it is able to what? Undertake them. So in this first quadrant, what we have looked at is that the definition is all presenting an artificial intelligence, either the hardware or the software, as being able to think what? Think humanly. Also, in the third quadrant in here, we still have AI having some definitions as suggesting that AI means that acting what? Humanly. That is different from thinking humanly, right? So Caswell in 1990 suggested that AI is the art of creating machines. It's the art of what? Creating machines that perform functions that require intelligence when performed by people. So all actions that we needed to undertake for which it required intelligence, if we are creating a hardware or software that can do the same, then by this definition, it is suggesting that AI is a set of either a software or hardware that can act what? Humanly, because human beings, that is how we act. Okay, we are able to undertake some tasks by making intelligent decisions. Likewise, 2 authors, Rich and then Knight, in 1991 also came up with a definition to suggest that AI is the study of how to make computers do things at which, at the moment, people are better. Right? So as it stands now, human beings are better at modeling vehicles, modeling aeroplanes, modeling computer systems. But yet, to improve it or move it further advanced, more than the level at which human beings can do them, AI has also come to play in the area of assembly of vehicles. A human being cannot work from morning to evening, but you can have a robot, a hardware robot that can assemble as many cars as possible. How many people are needed to lift heavy engines and then assemble a car? Our strength will not allow us to be lifting all of these heavy things, and then we will remain the same, right? So these robots come to play to improve or advance how human beings are able to do assembly of vehicles, right? Already, like the example I said in e-commerce, we are already doing well in the buying and selling, but the concept of e-learning has moved this further. So then instead of going through about 10,000 items before you can select one, the application will learn to know what you're interested in and then to suggest to you that this is good for you. And more often, these suggestions do not lie. In reality, you measure and you tend to understand that, yes, it is true. What the computer is suggesting to me is one of my best choices that I will need to pick up for. So they are that persuasive. They are that persuasive. Okay. So these 2 quadrants have looked at thinking humanly and then acting humanly. At this other side, definitions are suggesting that AI is thinking what? Rationally or acting rationally. Rationality is simply making the right decision based on popular norms. Okay, so in 1985, Chakniak and then McDermott also defined that AI is the study of mental faculties through the use of computational models. All right, so computational models are simply mathematical principles that help us to evaluate problems or solve problems. Okay, so in their perspective, evaluating the mental faculties through computational models is artificial intelligence. So there should be a mathematical model, and that will be judged with how human beings think, or you are modeling how human beings think using mathematical models. That is what in their projection they saw what AI to be. Winston also in 1992 presented AI to be the study of computations that makes it possible to perceive reason and then what act. So you can see that in this case of rationality, the emphasis of thinking rationally, or the emphasis of the intelligence, is purely based on what mathematical models or computational intelligence. Okay, even if you look at the fourth quadrant where we discuss and acting rationally, we still also see computational intelligence running through all of the concepts. So the rationality or the rationality of the artificial intelligence system is that the hardware or the software is based on what computational intelligence, which is typically mathematics based on probability, statistics, calculus, and all of these related mathematical theories. How they will help us to come up with projections on what the future could be, or how to solve some basic problems, right? So you could see from here that the first definition, Polly defines AI to be computational intelligence, which is the study of the design of what intelligent agents. Intelligent agents are simply models that help to make rational decisions given what a problem. In the next definition, Nielsen in 1998 also defined AI to be concerned with intelligent behavior in artifacts, which is also still measured using computational intelligence, right? So these are the four different paradigm shifts of definitions that we have on artificial intelligence that we fall under thinking humanly, acting humanly, thinking rationally, and then acting what? Rationally, right? Now, one of those approaches, or the very core principle for which artificial intelligence has relied on massively, is the theory called Turing test. The Turing test was proposed by Alan Turing. So it is his name that is used as the point of reference to this particular theorem, okay, called Turing test. And that was proposed in 1950. And then in his design, he came up with some satisfactory operational definition for what artificial intelligence is supposed to be. What is supposed to be. My colleagues, please, sorry for going off. So, like I was saying earlier on, the Turing test is the alias principle that had come up with artificial intelligence. And then with this, it tends to be the test bed for which all other theorems have been propounded on to the level of improvement for which we see in artificial intelligence for now. So the question is, what is this Turing test all about? The Turing test suggests that a computer passes a test if as you see over here, we have a human interrogator, we have a human being sitting behind a machine here, giving responses, and then we have an AI system. So the test is that if a human interrogator that is sitting at this point, okay, after posing some set of questions, right? The questions will go to number one, human, and then number two, the AI system. If it tends to be that the responses given cannot be identified, whether it came from the human or it came from the AI system, then they have passed the test. So it is like a typical situation when you go to a university's website, there is nobody sitting behind the website to give you responses, but there is a chatbot. And then the chatbot is chatting with you as if it is a regular human being. So then you cannot tell that if this is not a real human being, but it is an AI. Okay? In that situation where you cannot tell that it is not an AI, but it's a human being, then it means that the computer system has passed what? Has passed the test. Okay? Then it means that the AI has gotten to a very optimal level, right? So that is typically what a theorem is all about. So at the very fundamental level, these two entities, both the human and then the AI system, receive the question. But the machine seated here could not decipher whether the response came from the human being or came from what? The AI system. In that case, we would say the computer system seated here has passed what? The Turing test. It could be that it actually came from the AI system. So if the AI system has been able to respond, so then it suggests almost the same as a human being would do, then it tests 100% or almost 100% intelligent. That is basically what the Turing test is all about. Right, so now we're going to look further into details when we say acting humanly, what is fully about. It is acting humanly, like I explained earlier on, is we have partly explained that when we're discussing the Turing test approach. Okay, if the computer would be able to pass the test, then it must possess the following capabilities. It should have the natural language processing, which enable it to communicate successfully in English or in a specified language, right? So reading some other books, they may be referring to natural language processing in short as NLP. When we start with machine learning, we come to appreciate NLP so much. As it stands now, let me give you some practical examples. When you go to Google, you can type in English and then you would want it to be translated into, let's say, Arabic, French, Chinese, or Italian, any language of your choice. How is the computer able to do this translation? It is able to do this translation using machine learning and then deep learning techniques. Okay, specifically that is called RNN. The full meaning of RNN is recurrent neural network. It has been deployed heavily in the area of natural language processing. It can learn very well from the future or from the historical data to predict the future, and that has been used much with the natural language processing. Also, okay, so quite apart from the NLP, the computer must also have high capability in knowledge representation. That is how data is stored, to store what it knows or what it hears. Dominic, also, can you kindly turn off your video, please? So in the area of artificial intelligence, it is that much important how how data is represented. Most of these machine learning models or deep models, they understand data better when they are in their numerical forms. It even becomes much better when they are represented in zeros and ones. Okay, so how data is stored, how they are represented is also that much important. Number 3, also on automated reasoning. In the reasoning or the logic, the basis of the logic of the artificial intelligence system or the computer is not automated, then it will be very difficult that it can understand. As it stands now, the programming that we are able to do on the majority, we have to specify each rule one after the other. Okay, doing development in this manner is more than difficult. It is just so tedious. Imagine for example, you want to create a software that can identify people in a given image. How do you do that? Is you able to tell that this is a human being, this is an animal? How do you do that? Look at the number of features that we use to identify human beings, the number of features we use to identify animals. Some images will come blurry, some will come very sharp, some images will be taken in the darkness, some will be taken in the broad daylight. In some images you would have background, some will come with a plain background. Where it becomes more difficult is identifying where you're creating you are writing instructions, so then even amidst a given background, the software or the hardware can identify people in the image. It becomes so difficult. Okay, so automated reasoning is so much important that it can help that in the area of AI, the machine can perform better logical reasoning. And then moving on also, one of the very trending areas in AI, like I keep repeating myself on, is machine learning. And then in this course, we'll dwell more on machine learning, because when you understand machine learning very well, it is deployed. You deploy concept of natural language processing, knowledge representation, automated reasoning, all in machine learning and then in deep learning. Okay, so that has become almost like the central point of AI now. If you have the skill, it wouldn't only just help you to become a better teacher or a better instructor, but it will make you become highly employable. That is, if you want to leave the classroom. Okay, so put in a lot of effort trying to understand these concepts as we'll be going through them. So in machine learning, the idea is to help adapt to new circumstances and then to detect and extrapolate patterns. So in the area of weather forecasting, AI or machine learning is used in the stock exchange. AI is used in recommender systems, or let me put it well, in e-commerce. Recommender systems are deployed, so then it makes suggestions. These are all typical instances of what? The application of machine learning. Okay, and then we also have what you call computer vision. A lot of games that have been developed now do deploy the technique of what? Computer vision. That helps that the software or hardware is able to what? Perceive objects. So doing image processing and all of that and falls under the category of computer vision. And then the hardware aspect of AI is simply what we call robotics, and they are used to manipulate objects and then to move about. So in the Turing test, like we earlier on discussed, this machine should have will be capable of giving better responses only if it has all of these areas well deployed, well enhanced within it. Then it can come up with the best responses whilst it's interacting with a human being. So then it will be so much difficult for the human being to tell whether these responses are coming from another human being or it's coming from a computer system. Yes, the handwriting is not visible enough because I'm using the trackpad on my machine to do writing. I am not typing it out. Okay. So what I would do is instead I would enable captions. I'll enable captions so then also when I talk, you will see the writings below the panel. I should think as it stands now, it is active for all of you to see also. All right, so quite apart from acting humanly, we also discussed thinking humanly, which now falls on what? Cognitive science. It is the acting and thinking rationally that relied on what? Cognitive computational intelligence or computational science. But thinking and then acting humanly purely is based on what? Cognitive science, right? And that looks at the areas of introspection, psychological experiment, and then brain imaging to make inferences, and then conclusions could be what? Could be made. So by introspection, we will say that the AI system will try to catch our own thoughts as they go by. So as the activities are allowed to flow, it begins to learn the patterns and then to begin to make what? Adjustments. Okay, so it looks at the past to make inferences to suggest what the immediate activity is supposed to be. So majority of machine learning concept is to rely on historical data. Is to rely on historical data. By relying on historical data, you are modeling an idea of introspection, just as human beings would do. And then also psychological experiment by observing a person's action. And that by simply observing how someone would take some actions, you can understand the reasons why those particular decisions or directives were undertaken. In the third note is by brain imaging, observing the brain in action, right? There are several scientific theorems that have been used to understudy the functionality of the brain. Okay, all of these approaches are used in cognitive science to understand how AI models could be constructed, how they could be designed and then constructed. Now, by introspection, by psychological experiment, and then by brain imaging, we are able to come up with sufficient or precise theory of the mind, and then it helps and makes it possible to express a theory as what? A computer program. So all we are looking up to is that you are able to develop a software that mimics the intellectual behavior of what? Of the human being. And human beings do introspection. We do psychological experiments and we do brain imaging. Okay? And then also the interdisciplinary field of cognitive science brings together the computer models from AI and experimental techniques from psychology to construct precise and then testable theories of the human mind. Okay? Right, so that is it about thinking humanly and then acting humanly. Now we're looking at the third and then the fourth quadrant issues. That is thinking rationally and then acting rationally. This is purely based on the laws of what? Thought approach. What are the laws of thought approach? If you have heard of this popular name, Aristotle makes some syllogisms that suggest that patterns for argument structures that always yielded correct conclusions when given correct premise. A very typical example of this is when by this example. One, Socrates is a man. All men are mortal. Therefore, Socrates is mortal. If Socrates is a man and all men are mortal, then you can go ahead to conclude that Socrates is also what? Is also mortal because he is a man. So these laws of thought were supposed to govern the operations of what? The operations of logicians in the 19th century, to develop a precise notation for statement about all kinds of objects in the world and then the relations among them in relation to the mind, just study to initiate also the field called what? Called logic. Okay, so it is logic that makes this statement what? Right. So then the first part of it is that Socrates is a man, and then the next side defines whom a man is, that all men are mortal. So Socrates is a subset of men. He is one of the objects or prototypes of a man. So if all men are mortal, then you could go on a logical conclusion that Socrates is what? Is mortal. If this statement is right, then we can use this, you can create a mathematical notation to represent this. So then that mathematical notation can equally be translated into what? Into a possible software. Just like in the general notation, we can convert an algorithm. We can convert an algorithm to a pseudocode algorithm. That's my friend who said, what I'm writing is not clear. When you go to the doctor and then he's writing medication for you, it's not clear. Do you complain? You're only supposed to take you to the pharmacy shop and then they'll pick medicine for you. It's sanity. Writing like a doctor in the classroom. I'll try and see if I can get an external mouse that will allow me to write better next time. Now, next classroom classes. I should think even with those ones, I wouldn't need to be writing. I will instead be typing quotes. So we wouldn't have those these problems in our subsequent meetings. Okay, I am sure of that. All right, so we write algorithms, convert our algorithms into pseudocodes, and then from a pseudocode we draw some flowchart. After we have drawn our flowchart, we are able to write what? Our code for a particular what? Based on a particular programming language. Okay, so similar manner. If you're able to build the logic, then the logic is what we translate into what? Algorithm, translate into a pseudocode, translate into a pictorial view called the flowchart, and then we bring it back, bam, into what? A code, right? So coming up with this logic from the cognitive science and then the computational sciences will help to come up with notations that will represent, that can be translated easily into what? Into a software program. Now, two main problems come with this approach. It is not easy to take informal knowledge and state it in the formal terms required by logical notation, particularly when the knowledge is less than what? 100% certain. It may not follow all the time that all men are mortal. It may not, unless you are looking at this in the principal notation of religion. If you look at this in the spectacle of religion, then men must remain mortal all the time. However, in the early creation of man, as stated of the Bible, men were made what? Immortal. We became mortal precisely only after we ate of the fruit. This fruit has really worried the world. Okay, so if that remains true, then this statement becomes what? Arguable. So then we will say man from the beginning had not been mortal throughout until after what? after the evolution of sin. Okay, so that becomes arguable because in that case we will say it is not 100% what certain. There are some uncertainties. The second problem following this logic is that there is a big difference between solving a problem in principle and solving it in what? In practice. So by the principle of this logic, it could be true, but in solving it, it may not be 100% true. Okay, one of you is mentioning that you cannot hear me. Please, let me know from all of us if you can hear me or you cannot. Just respond by saying yes or no. If you can hear, say yes. If you cannot hear me, also say no. Right. Then, Audrey, I said, we did tell sound. My friend, on a more serious note, you can maybe refresh your browser. I'm sure when you refresh your browser, it will reinstate the hearing. Okay. And then position yourself somewhere where the network signals may be much better. And from there, I should think we shouldn't have problem in our communication. Okay, so looking at the last quadrant, that is acting rationally. So this will be based on a rational agent. So now we want to look at exactly what an agent is. Agent, in Accra, we have a lot of agents. If you want to rent a house, you need an agent. Sometimes even if you want to marry, you need an agent. Don't mind me, I was just kidding on that. So what are agents in the area of artificial intelligence? An agent is just something that acts. So anything that acts is an agent. So of course, all computer programs do something, but computer agents are expected to do more. Operate autonomously, perceive their environment, persist over a prolonged time or period, adapt to change, create, and then perceive what? Those. So more specifically, what we're looking at is the concept of an agent in the area of what? Of AI. So operating autonomously is a key. It should be able to act independently after that model has been built. So then even if there are abstractions, it will not have to affect the functionality of what? Of the artificial intelligent model or software or hardware that has been what? Created. It should also be able to highly perceive its own environment. So in building AI, you can build AI robots that is supposed to walk. It can walk around only when it can perceive what? Its environment. That is why we said earlier on that to pass the Turing test, one of those arguable parameters for which the machine needed to process was what? Computer vision. Computer vision is what makes that software or hardware robot be able to identify or perceive objects. In the absence of that, the AI robot or software cannot perceive what? Objects. So the laws of thought approach to AI, the emphasis was on correct what? Inferences. That is, making correct inferences is sometimes part of being a rational agent. Okay, so let me repeat myself on this issue of rational agents. Rational agent is one that acts so as to achieve the best outcome, or when there is uncertainty, the best expected outcome. So in the midst of given discrepancies, even in historical data that is given to a particular learning model, the expectation is that it should be able to still predict the best. So for example, in weather forecasting, we can have some values that are outliers. So then, for example, you want to say that you are 100% sure it will rain in the afternoon only when the temperature is, let's say, 56 degrees Celsius. Humidity is at, let's say, 25, whatever. And then the reading of moist in the air is also at a particular value. So If it happens that these are the standardized rubrics and then there are outliers, so then instead of temperature reading 56 degrees Celsius, it reads, let's say, 85. 85 may not follow the normal norm in suggesting that it should rain heavily. That becomes what? An outlier. But that particular outlier should not affect the perception in which the model will base on to do what? Prediction. Okay? So in the conclusion of acting rationally, what we will say is that the Turing test allows the agent to act what? Rationally. And that is a skill set that is built on knowledge representation and then reasonable agents to reach good decisions would all still have to have these capabilities that we mentioned earlier on that must be processed by a computer system to aid it pass what? The Turing test. That is on the natural language processing, on the knowledge representation, automated reasoning, machine learning, computer vision, and then robotics. All of these capabilities must come clear together in one model so then the system can pass the Turing test. So these are the four variants that comes up with the definitions of what? Of artificial intelligence. Now, coming to the very latter part of our discussion before we close for today, we're going to look at the broad perspective of the history of artificial intelligence. Artificial intelligence has not come up from the skies. It has concept of philosophy, mathematics, psychology, economics, linguistics, neuroscience, and then control theory, all coming together to form what? The very background of artificial intelligence. Okay, so in philosophy, we are able to by that build the logic, build methods for reasoning, mind as physical systems, foundations of learning, the language, and then rationality. Okay, that these are the contributions that are made by philosophy. In the contribution made by mathematics help us to create formal representation. So coming up with notations that will help to translate an idea into a mathematical model that can subsequently be written as a code. It is all by the help of what? Mathematical principles. Okay, so proof of algorithms, computation, decidability and undecidability issues, tractability and untractability issues, and then probability. All of these things are the contributions made by what? By mathematics. In this presentation, I have neglected the dates because the dates are not necessary, so much necessary for this discussion. But when you go back to the books, if you are interested in dates, you can look at them. But going through the history, I tend to realize that these particular areas have contributed enormously to the advances of artificial intelligence as we see now. So quite apart from physiology, mathematics, also psychology plays a role. So adaptation, you might have heard of persuasive technology. Persuasive technology. Persuasive technologies, they are either software tools or hardware tools with concepts that will help change the behavior of people most of the time for a positive action to be taken, right? So people who would more often not be organized. There could be a game that if you play, as you arrange things in the order as they must be, you are given some increment in scores, or your scores are increased. By playing the game over a time, that game will begin to influence your normal human life behavior. There is this this game called Mongo. Is it MongoDB? Yes. As the game is modeled that it has virtual reality. As you pick trash around you, you score more marks. So if it is outside of your room or inside of your room, as you turn the game would turn on your camera, and then it will point items that it thinks that they are not well organized or they are trash, they must be put in the trash can. So anything it will tag as trash, for which more often they are 100% correct. When you pick them and put them in the trash, you score a point. As you play this game over time, it will influence your normal behavior. So then earlier on, if you bought ice cream, you sip it and then just throw away the cups around. This time around, it will change your mentality because the game has influenced you. You want to score more points all the time in the game, and that will influence your real life behavior also. So you want to score more points. By that in the game, natural life is also influenced, and then we call these technologies that are influencing our regular choices as what persuasive technology, and that is 100% borrowed from psychology. The psychology that deals with how human beings do reason. Okay, so also the perception of phenomena and the motor control experimental techniques, psychofixes. All of these things are contributions made by the area of psychology into building artificial intelligence models. And then also economics. I give an example of where machine learning and deep learning have been deployed. I mentioned stock exchange prediction.
It's 8 o'clock.
You can only have a very good model predicting these things, given the background principles of economics. So they contribute formal theory of rational decisions on economic issues. And then based on these principles, you can build a software that will help come up to make reasonable or rational decisions. And then the area of linguistics, like we mentioned earlier on, natural language processing is one of the outlets of artificial intelligence. What's the purpose? It's to give reasonable interpretation to instructions that are written, statement, information, data. And that heavily relies on what? Linguistics. So grammar, knowledge representation. These have been the two major contributions given by the area of linguistics. And then we also have neuroscience and then control science. While neuroscience is adding on to the area of plastic physical substrate for mental activity, control science has also contributed to the homeostatic system stability, simple optimal agents designs, and more of them. So this is the very summary of the history of artificial intelligence. Now we're going to look at the state of art. What is happening now? What is happening now with artificial intelligence? We mentioned driverless vehicles. Driverless vehicles as stands now are deployed in some developed countries. There are some you have heard of Tesla, right? Tesla is typically an electronic vehicle, and all of these advances in a car, for example, Tesla, is heavily relying on artificial intelligence principles, right? So back again on this, robots have been deployed in current cars. So then sitting in a car and then being able to identify that you are not putting on your seatbelt, that is AI. Some of the cars, once you drive beyond some speed limit, it begins to apply some amount of brakes on its own. So then you can't go beyond some limits. That is typically AI. The earlier example I gave also on driverless vehicles. So there's no driver driving you, but the car can move from one point to another. That is typically artificial intelligence. And then also on speech recognition. Now you can talk to a machine. You can tell your phone using, for example, Siri, that call my father, call my mother, call my wife, call my girlfriend, call Akosto Japan. And then it will respond. It will call exactly the name. Or you want to open an app. You talk to the app, Siri. Hi Siri, open the particular named app, it will open it up for you. How is the phone or the laptop or the computer able to recognize your voice? It is typically based on what? Speech recognition systems, or typically based on artificial intelligence techniques. And then we also have autonomous planning and then scheduling. There are several autonomous planning and scheduling applications. For example, NASA's remote agent program. It became the first onboard autonomous planning program to control the scheduling of what? Operations for spacecraft. Okay, so autopiloting and the like, all of these things are made possible because of what? Artificial intelligence. So we have mentioned the area of robotic vehicles, speech recognition, autonomous planning and scheduling, and then in the very final areas we are looking at in the area of games. So we can look at the IBM Deep Blue, which became the first computer program to defeat the world champion in a chess match game when it did beat the very best, Gary Kasparov, by a score of 3.5 to 2.5 in a division match. Okay, this guy has not been beaten by any human being before, but on chess. But when AI was deployed in chess, the AI did beat him. Okay, so you can see how much intelligence these systems could become based on how they are trained. They are also used in the area of what? Spam filtering. So then when you are receiving a mail, the mail, you're able to identify the mail as either a spam or not a spam. Okay. And then also in the area of robotics, AI has been used heavily. So then robots can do navigations on their own. They can perform a lot of activities on their own. A typical example is the iRobot Corporation, which has sold 1 million of Roomba robotic vacuum cleaners for home use. Okay, so these robots are able to do a lot of cleaning, domestic cleaning by themselves. And then also, finally, in the area of machine translation, which is a computer program that automatically translates from Arabic to English, allowing an English speaker to see the headline. Erdogan confirms that the Turkey would not accept any pressure, urging them to recognize Cyprus. This program uses statistical model built from examples of Arabic to English translations and from examples of English to text, totaling 2 trillion words. Okay, so that is how much of volume of words that it bases on to do what? The translation. So this, as it stands now, is the state of art, the very current state of advances of AI that we have, in deployment in robotics, in speech recognition, autonomous planning and scheduling, in the area of gaming, in the area of identification of spam, in robotics, and then in machine translation. My good friends, I think this should be a good introduction for you to be able to easily relate to what artificial intelligence is all about. So in our subsequent classes, like I mentioned earlier on, do install Anaconda, and then we'll be using that as the basis for our development. I hope that you would all give in your best